Now we're going to explore the difference between average and instantaneous values. Now, if we look at the definition of velocity, v we know equals to ds dt, but sometimes we may have seen velocity written as delta s, delta t. Now, what is the difference between these two? Now, when we express it as a differential ds dt, we are in fact finding the instantaneous velocity. And when we do it this way, delta s over delta t, we are finding the average velocity over the period delta t. Now, let us understand what this means graphically. So if I draw a simple ST graph, okay, it could be anything, ST, and it maybe looks something like this, okay. Now, if I ask for the instantaneous velocity, I must specify a particular instance, okay. For example, I want the instantaneous velocity right here. And that is where you draw a little line up and you find the gradient of the tangent of this curve at that value of t. And hence ds dt, which means gradient, and that's exactly what you're doing. And so the gradient of this is your v instantaneous. Now, what about average velocity? Now, the average velocity, I have to specify a time interval. And so I could say, what is the average velocity from start to this point? And in which case, you take the total change in s, which is this, delta s, and of course the total time interval specified, delta t, and you simply divide them. And so in essence, what you're doing, you're finding the gradient of this green line over here. That is v average. And so you can see quite clearly that there is a remarkable difference between instantaneous and average velocities. And so we always have to be very clear about this when we're doing our questions.